Hello, me again. Welcome to this presentation on atom economy. I do expect you to come with some knowledge. The only real knowledge that you need in this particular one is how to work out relative molecular mass. Christmas dinner is wonderful. However, in my family, not everybody enjoys the Brussels sprouts. Personally, I like them. My family don't want them even on their plate. And chemical reactions are kind of the same. If I take two flasks, mix them together, do a chemical reaction, I'm going to make stuff that I want. Brilliant! However, quite often I also get stuff that I don't want. If I take two reactions here to show how to make magnesium oxide, I've got magnesium metal reacting with oxygen, I'm going to make magnesium oxide. I might take magnesium carbonates though and do a thermal decomposition to also make magnesium oxide, but I get carbon dioxide as a byproduct. Okay. If I was an industrial chemist and I wanted to make 10 tons, a million tons, 1,000 tons, whatever it might be, I'd probably choose the top reaction just because it only makes one product, which means I've got less purification to do. It is the only useful product. Here, at the bottom reaction, I still make my useful product, don't get me wrong, but I also make some carbon dioxide. I need to get rid of that carbon dioxide. But the bottom reaction has another problem, in that I waste some of the atoms that I started off with. And we need to work out the percentage of that. So atom economy then is the mass of the products you want as a percentage of the mass of all of the products you make. Well, I only make one product in this reaction. So actually, the percent of the mass of the product that I want is 100%, because it's the only product there. So if you only make one product, your atom economy is always going to be 100%. If I think about the other reaction that I showed you, so the thermal decomposition, I make two products. And I need to be able to work out a percentage or the atom economy of this. Okay, and I do this using the equation here, the mass of the useful products divided by the mass of all of the products times 100%. So I need to work out the masses, which essentially is the relative molecular mass. So the MR of magnesium oxide is 40, the MR of carbon dioxide is 44, and therefore my atom economy using that equation is 40 divided by 40 plus 44. And once you turn those numbers around, it comes out as 45.5%. So 45.5% of the mass of the atoms in my products end up in the product that I want. But that means that the rest of it, the 54.5% of atom mass of the atoms end up in the carbon dioxide. Not the best, okay? So, got a couple of problems for you to try. If you react iron oxide with carbon monoxide, you make iron and carbon dioxide. Assuming you're going to try and make iron, what is the atom economy of that reaction? And using this displacement reaction now of chlorine and potassium iodide, you're going to make potassium chloride and iodine. What is, assuming that you want the potassium chloride, what is the atom economy of this reaction? So pause the slideshow. I said pause. Thank you. And here are the answers. So the atom economy of the first reaction is 45.9%, and of the second reaction is 37.0%. If you didn't get those, make sure that you've calculated the MRs correctly, and make sure you pay attention to the numbers in front. So how many ions, how many carbon dioxides are there, etc. Okay, thank you very much for watching. Until next time, bye bye.